Hey folks, welcome back to this tutorial on Python. In the previous videos, we have learned that Python has a few versatile and flexible data types. In this video, let us learn more about those data types. Atomic data types, like int, float, complex, none, and Boolean data types are pretty simple. But collection data types, otherwise known as iterables, have some methods associated with them that give a lot of power to the developers. Let us have a look at them, one by one. First up, let us have a peek at the text data type of Python, strings. Python strings are versatile. They can hold any number of characters. Unlike some other programming languages, there is no character data type. In Python, a single character is just a string of length 1. This makes things less complicated when we get down to code. As always, practical way is the best way. So, let us look at some examples of string methods in action. Python strings are armed with a lot of helpful methods. In fact, strings have the most number of methods among all the iterables in Python. For the sake of simplicity and easy comprehension, the methods have been categorized according to their functionality. The first category we'll be looking at is case manipulation. We have quite a few methods for playing around with the case of the characters. We can convert the string into uppercase, lowercase, swap the case, and so on. Let's look at each method with some examples, shall we? The method, upper, converts the entire string into uppercase. This is fairly straightforward. The capitalize method converts the first character of the string to uppercase. All the other characters in the string are converted to lowercase. The next method, title, converts the first character of every word to uppercase, and everything else to lowercase. In other words, capitalize method will convert the entire string to lowercase, except the first character of the entire string. The title method converts the first character of every word into uppercase, while converting the rest to lowercase. If the word starts with a non-alphabetic character, the first alphabetic character would be converted to uppercase. For example, look at the door number. 177 is not alphabetic. Hence, the first alphabetic character after 177, which is A, has been converted to uppercase. The method, lower, converts everything to lowercase. Pretty simple. The casefold method functions in a similar way, but it has a wider scope. For example, it can convert German characters into lowercase, while the lower method cannot. So, in other words, casefold method can be used in an international context, while the lower method can be used in the context of English language. The swap case method functions according to its name. It converts lowercase to uppercase and vice versa. We have 3 different methods to check if a string contains numeric characters. These methods help in checking if the string is composed of specific numerical characters. Let's look at some examples. Of the 3 methods, isNumeric is the most inclusive. It recognizes decimal characters, fractions, superscripts, subscripts, and other number systems, like Roman numerals and Arabic Indic numerals. The isDigit method recognizes fractions, superscripts, and subscripts. It does not recognize other numeral systems. But the isDecimal method recognizes only base 10 numerals, that is, the digits 0 to 9. The isDecimal method is the most restrictive of the 3 methods. One thing to note about these 3 methods is that these methods are encoding agnostic. For example, if we encode the number 5 into UTF-8 encoding, and then check with isDecimal method, it would still return true. The next set of methods are focused on characters, not strictly numeric. They check if the string is composed entirely of the specific category of characters. Even if there is a single character that is not of the specific category, the method returns false. The is-alnum method checks if the string is composed entirely of alphanumeric characters. Presence of a special character will cause the method to return false. The is-alpha method checks if the string contains only alphabetic characters. Even if there is one non-alphabetic character, it will return false. The is-ASCII method checks if all the characters are in the scope of ASCII characters. Characters of other languages are not recognized by this method. The is-identifier method checks if the string can be used as an identifier. An identifier is a string that can be used as a variable name, or a function name, or a class name. However, this does not check if the string is a keyword or not. If the string is a keyword, the is-identifier method would still return true. The is-printable method checks for printable characters. Whitespace characters like new line and tab are considered to be unprintable, the exception being space. The is-space method checks if the string is composed entirely of whitespace characters. Python strings have methods for alignment. We can easily align the string in a fixed number of placeholders. Center, left align, and right align are the three options available. When the number of placeholders are specified, the methods align the string in those placeholders. For example, in the following examples, the string apple is aligned among 9 placeholders. The pipe symbols are just for understanding the end of the placeholders. There are methods to check if the string is composed of uppercase or lowercase characters. There is also a method called isTitle, which checks if only the first character of every word is in uppercase. Here are some examples demonstrating those. The isUpper and isLower methods are pretty straightforward. The isTitle method checks if all the words in the string have only their first characters in uppercase. In the first example, apple, banana, and cherry have their first characters in uppercase. So the method returns true. In the second example, only the first word has its first character in uppercase. So the method returns false. Let us now have a look at the methods that are useful for data cleaning. If you're a data engineer or a data scientist, you will often find yourself using one of these methods. Data cleaning and pre-processing is one of, if not, the most important step in data science. If you are working with natural language, you would be required to clean up the data, which often requires removal of special characters. These methods, along with the replace method, are of immense help in that area. The lstrip method removes all the specified characters in the beginning of the string. The rstrip method removes all the specified characters in the tail end of the string. In the first example, the lstrip method removes hyphens from the start of the string. In this case, there are 3 hyphens, and all of them are removed. The same is the case with rstrip method. All periods are removed towards the tail end of the string. So, the lstrip and rstrip methods remove any number of specified characters in their respective parts of the string. The strip method is a combination of lstrip and rstrip. It removes the specified characters from both ends of the string. Again, the characters are removed, regardless of the number of occurrences. In this case, the hyphens and periods are removed by the strip method. For all the 3 methods, strip, lstrip, and rstrip, the default argument is a space. If no argument is given to the strip methods, the spaces at the applicable ends of the string are removed. The remove prefix and remove suffix methods are similar to lstrip and rstrip methods respectively, but they remove only one occurrence of the specified characters. In the given examples, the remove prefix method removes only one hyphen, and the remove suffix method removes only one period. We need to be a little cautious when using the strip methods, because they remove all the specified characters at the ends. But the remove prefix and remove suffix methods offer some control, as they remove only one character at a time. Join, split, rsplit, and splitlines are the methods used for splitting and joining the strings. It should be noted that joining is much different from concatenating. Concatenating two strings does not require a separate method. We can use f-strings, or the addition operator, to concatenate two or more strings. Joining is a little bit different. Let us have a look at an example to understand more. In the first cell, we have two strings. One is a hyphen, and the other is apple. When we join the second string, apple, with the hyphen is sandwiched between the characters of apple. This is worth remembering, because the argument to the join method does not strictly have to be a string. It can be a list, or a tuple, or a set. In all the cases, the first string is sandwiched between the elements of the argument provided to the join method. The split and our split methods are used to split the string using a delimiter. They take in two optional arguments. The first optional argument is the delimiter. The default delimiter is a whitespace character, like a space or a new line statement. The second optional argument is the number of splits. The split method starts the splitting from the left end, and the rSplit method starts the split from the right end. In the example, the number of splits provided is 1. So, the split is done at the comma, only once. The split method starts the splitting from the left, and gives a list containing apple and banana, cherry as the output. The rSplit starts the splitting from the right, and gives apple, banana, and cherry as the output. If there is no mention of the number of splits, both these methods give the same output. The example in the third cell demonstrates that the default delimiter is a whitespace character. The string is split at spaces and new line characters. The split lines method splits the string at only new line characters. Python strings provide us with the option to locate and replace the characters in a string. The find, index, and replace methods help in this regard. The find and index methods function in a similar way, returning the index position of the first occurrence of the character, starting from the left. The difference between these two methods is evident when the character is not found in the string. When the character being searched for is not found in the string, the find method returns a -1. But the index method raises a value error. The rFind and rIndex methods do the same thing, but they return the first match from the right. As usual, examples are much better than theory. In the first cell, we can see that the index and find methods function the same way. They look for the first occurrence of the character or substring man and return their index position. Since the indices start with 0 in Python, the position of first occurrence of the substring man is 5 when looked from the left. It occurs as part of the name Superman. The rIndex and rFind methods do the same thing, starting from the right. The first occurrence encountered by them is part of Batman. So they return the index position 16. Replace method is fairly simple. It replaces all the occurrences of the first argument with the second argument. It takes an optional limit to restrict the number of replacements. In the example, the substring frenemies is replaced with the substring friends. As discussed earlier, the index method throws a value error exception when the character or substring is not found. The find method returns a -1 in this case. Partition and rPartition are the methods used to partition the strings in Python. Let us jump into a quick demo of these methods in action. The partition methods are a bit similar to the split methods. They split the string, taking the delimiter. While the split methods return a list as output, the partition methods return a tuple, containing strictly 3 elements. The first element is the part of the string before the delimiter, the second part is the delimiter itself, and the third part is the part of the string after the delimiter. The partition method splits the string into 3 parts, at the first occurrence of the delimiter from the left. The rPartition method does the same, but it splits the string at the first occurrence of the delimiter from the right. The example clearly demonstrates this. To check if a string starts or ends with a specific character, or even a substring, we use the starts with and ends with methods. The starts with method checks if the string starts with the specified substring. The ends with method checks if the string ends with the specified substring. These methods return a Boolean value as output. String formatting is useful when parts of the string are to be dynamically decided. Formatted strings are the precursors to F strings, which we saw in an earlier video. The format method takes a number of named arguments and replaces the placeholders in the string with the corresponding arguments. If the arguments are unnamed, the replacements are made according to position. In the first example, the name, codename, and universe are the named arguments that are used to replace the placeholders in the template string. The format map method does the same thing, but it takes a dictionary as argument. These methods are very useful when we need to dynamically change the output string, depending on the input. For example, if you are designing a prompt for a large language model, and you need to replace specific words in the prompt, you can make use of format or format map methods. If you need to store the template strings, formatted strings are the best way. Though F strings are helpful, they strictly require the values for the placeholders, which restricts storage. Since formatted strings are essentially strings, they can be easily stored. The values are required for the placeholders only when the format or format map method is called on them. To change the encoding of the string, or to efficiently replace the characters in a string, these methods can be used. The default encoding standard is UTF-8. But, if the need arises, we can easily change the encoding of the string to UTF-16, or ASCII. This is evident if the string contains special characters like accented characters, characters from other languages, etc. The translate method is used to replace characters in the string in an efficient way. It is very similar to the replace method, but is more efficient. Also, they can replace only characters, while the replace method can handle characters and substrings. The implementation of translation requires two methods, makeTrans and translate. The makeTrans method prepares a translation table, and the translate method uses the table to replace the characters. The translate method can replace multiple single characters in an efficient way. We cannot limit the number of replacements. All characters will be replaced. But in the replace method, we can limit the number of replacements. The differences are demonstrated here. Having seen quite a few methods, it is evident that Python strings are feature-rich. Here are the last three methods: count, expand tabs, and zfill. The count method is used to count the number of occurrences of a substring. The expand tabs method is used to specify the number of spaces for a tab. By default, one tab equals 8 spaces. The zfill method prefixes the string with zeros. In the expand tabs example, the method replaces the tab character with 4, 6, and 8 spaces as provided in the list. We have used the built-in function, reaper, to print the strings in raw format. In the zfill example, the string is prefixed with zeros. It takes an argument, which decides the final length of the string. 5.12 is a string of 4 characters. Zfill of 6 means the output string should be 6 characters long. So 2 zeros are prefixed. This marks the end of string methods. Next up, we'll look at the methods of Python lists. Python lists are versatile, flexible, and can contain elements of any data type. They are mutable and can be of any length. It supports item assignment, addition, update, and delete. Let us look at the methods it offers. These are the methods available with Python lists. Though not as numerous as the methods in strings, these are more than enough when dealing with lists. The append method appends an element to the list. We can even append a list as an element to a list. Clear method removes all the elements from the list, effectively rendering the list empty. The copy method makes a deep copy of the list. It creates a new list in a different memory location from the original list. This is different from shallow copy, which is creating a new object that points to the original list in the same memory location. The count method counts the number of occurrences of a particular element. This is similar to the count method in string. The extend method adds the elements individually to the list, instead of appending it as a single item. This is the difference between append and extend methods. We can get the index position of the first occurrence of an element using the index method. Quick reminder, the indices start from 0. So the second element of the list is at index 1. The insert method can be used to insert an element at a particular position. In this example, we insert the character B at the position 1. The pop method is used to remove the element from a specific index position. If no position is specified, the last element is popped by default. The remove method is used to remove the first occurrence of the element. Pop method takes in index position, while the remove method takes in the actual element to be removed. Note that only the first occurrence of the element is removed. Sort method is used to sort the list. The optional argument, reverse, is used to sort the list in descending order. The list is sorted in ascending order by default. The reverse method is used to reverse the list. Python supports reversing the list using slicing syntax, start, stop, and step. Refer line number 8 for the code to reverse a list, using the slicing syntax. The absence of lower and upper bounds indicate that all the elements are included. The step size of -1 indicates that the elements are read from the right, which essentially reverses the list. This slicing syntax can be used to reverse a string as well. That's the end of this part on list methods. Coming up, a short session on the methods of tuples. Since tuples are immutable, they have only two methods, count and index. They work in the same way as their list counterparts. Python sets support all traditional set operations like union, intersection, difference, etc. Sets are mutable collections that hold unique items of any immutable data type. So, a set can contain numerical elements, strings, and tuples. But mutable data types like lists and dictionaries cannot be elements of a set. These are the methods offered by sets in Python. As these are standard set operations, let us quickly skim past, without delving deep. The add method adds an element to the set. If the element already exists in the set, no action is performed. The clear method removes all elements from the set, making it an empty set. The copy method creates a deep copy of the set. The difference method calculates set difference, that is, the elements present in the first set, but not in the second set. Set difference is not commutative. In other words, x minus y is not equal to y minus x. The pop element removes a random element from the set. A random element is removed because the sets are unordered. There is no guarantee that a specific element would be popped. Remove and discard methods do the same thing. They remove an element from the set. But the difference is that the remove method raises a key error exception when the element to be removed is not present in the set. Discard method performs no action if the element to be removed is not present in the set. Intersection method returns the common elements among the two sets. Union method collates both the sets, and returns a set containing all the unique elements from both the sets. It should be noted that all the above set methods return a set, after performing the appropriate operation. But there are some in-place methods that modify the first set instead of returning a new set. Let us start with the update method, which is an example of in-place operations. Here the elements of the second set are added to the first set. Note that the update method does not return anything. The first set is modified as a result of this operation. There are a couple other methods like intersection update, difference update, and symmetric difference update, which perform the appropriate operation on two sets, and assign the result of the operation to the first set. The is-disjoint method is used to check if two sets are mutually exclusive. In other words, is-disjoint method returns true if there are no common elements between the two sets. The is-subset method is used to check if the first set is a subset of the second set. That is, it is used to check if all the elements of the first set are present in the second set. The is-superset method is used to check if the first set is a superset of the second set. That brings us to the end of this part on set methods. Let's jump over to dictionary methods. Dictionaries are the mapping data type in Python. They are composed of key-value pairs. They are of immense help in caching and memoization. They serve as lookup tables, graphs, and so much more. These are the methods offered by dictionaries. We can see that the clear and copy methods are common to lists and sets. The clear and copy methods function in the same way as their list and set counterparts. The FromKeys method creates a new dictionary from the keys of the original dictionary, setting a default value for all the keys. If no default value is explicitly provided, the null value of Python, none, is set as the value. The keys and values methods return a list of the keys and values of the dictionary. The most common and straightforward way of looking up the value of a key is using the square bracket notation. We can easily pass a key inside square brackets, and the value will be returned. The problem with this approach is that it will raise a key error if the key is not found. So, the preferred way to get the value is using the get method. If the key is present, the corresponding value of the key will be returned. If the key is not found, it will return a null value. We can also explicitly specify the value to be returned if the key was not found. In this example, the error message, "No fruit name available," will be returned if the key was not found. The items method returns tuples of key value pairs. The pop method is used to pop an item in the dictionary by specifying the key. The key value pair corresponding to the given key would be removed. It also returns the value of the pair that was dropped. The pop item method behaves in a similar fashion. But it removes a random key value pair and returns it. The setDefault method is a method that takes in a key and an optional default value. If the key is present in the dictionary, no action is taken. But if the key is not present, the given value is updated. If no value is specified, null value is set as the value for the key. The update method adds the key value pairs of a second dictionary to the first dictionary. If the key already exists, the value from the second dictionary takes precedence. This is an in-place operation. Alright folks. This has been a rather long session on the methods of the iterable data types in Python. Hope this was informative. Until next time, happy learning. Keep practicing. Like, share, and subscribe for more.